am going to discussing about the areas. One problem, the area of the region lying between the lines x minus y plus 2 is equals to 0 and the curve x is equal to root y is first option 9, second option 9 by 2, third option 10 by 3 and fourth option none. Solution, we have to find the point of intersection of the line and the curve given x minus y plus 2 is equal to 0 and x is equal to root y. Here y is equal to x plus 2, squaring on both sides, x square is equal to y. It is equation number 1 and equation number 2. Y equal to x square, y equal to x plus 2. Now equating 1 and 2, come from 1 and 2 equations, x square is equal to x plus 2, x square minus x minus 2 is equals to 0. Now can factorizing x square minus 2x plus x minus 2 is equals to 0, x into x minus 2 plus x 1 into x minus 2, x plus 1 into x minus 2 is equals to 0, x is equal to minus 1 and x is equals to 2. The curves intersect minus 1 and 2. Draw a rough figure, minus 1 here, 2, x is equal to minus 1, x is equal to 2, which is parallel to y axis, and the given curve is x square is equal to x is equal to root y, x square equal to y square. This is x is equal to root y, x is equal to root y curve, and x minus y plus 2 equal to 0. The curve meets x axis when put y is equals to 0, y equal to 0, x value is minus 2, x value minus 2. If y is equals to 0, that implies x is equal to minus 2. Therefore, minus 2 comma 0 is the one point of intersection, and x is equal to 0, that implies y is equal to 2, x is equal to 0, y equal to 2, 0 comma 2. Now the required area is this part only, because of x is equal to root y. X is equal to root y means x square is equal to y, x is equal to plus or minus root y, but given curve is x is equal to only root y, we can take this region only. Required area is equals to integral of 0 to 2, integral of 0 to 2 upper line minus parabola. Line is given y is equal to x plus 2 minus y is equal to x square dx, that is equal x square integration of x square by 2 plus 2 into integral dx is x minus x cube by 3, lower limit 0, upper limit 2, that is equals 4 by 2 plus 2 into 4, upper limit minus 8 by 3, upper limit minus lower limit 0. 6 LCM, 12 plus 24 minus 16, that is equals to 36, 20 by 6, that is equals 10 by 3 square units, 10 by 3 square units. which is the solution of the given problem. 10 by 3, third option is the correct option. Next problem, the area enclosed between the curve y is equal to log of x plus e to the base e and the coordinate axis is first option 1, second option 2, third option 3 and fourth option 4. First, draw the graph of the logarithmic function log x plus e to the base e. Here 1 minus here, see the given curve is y is equal to log of x plus e to the base e. If the curve meets x axis means y is equal to 0. If y is equal to 0, that implies 0 is equal to log of x plus e to the base e. Now by the definition of logarithm, e power 0 is equal to x plus e. E power 0 equal to 1 is equal to 1 x plus e, that implies x is equal to 1 minus e. Therefore, the curve is like this, x is equal to 1 minus e, which is the region of from 1 plus 1 minus e to 0. Therefore, required area is equals to required area. Coordinate axis is x axis, here y axis equation of y axis is x is equal to 0 and the coordinate axis is integral of 1 minus e to 0 y dx, that is equal integral of 1 minus e to 0 log of x plus e to the base e dx. The second function is treated as a 1 by integration by parts. ILATE, inverse logarithmic algebraic and exponential trigonometric functions, ILATE. So logarithmic function in this integral, logarithmic function is the first function and 1 is the second function. By integration by parts, first function into integral of second function, log of x plus e first function into integral of second function, integral 1 dx is x, limits 1 minus e to 0 minus integral of 1 minus e to 0. Derivative of first function is 1 by x plus e into derivative of again x plus e 1 into integral of second function. Integral of second function is integral 1 dx is x dx, that is equal x into log of x plus e limits 1 minus e to 0. Now integral a to b f of x dx is equal to minus integral b to a f of x dx. Now the limits changes 0 to 1 minus e x by x plus e dx. Since integral of a to b f of x dx is equal to minus integral of b to a f of x dx. Applying this formula here, integral of a to b f of x dx is equal to minus of minus, here also negative sign, minus of minus plus b to a f of x dx, that is equals to x into log of x plus e to the base e limits 1 minus e to the 0 plus, now adding and subtracting e here in this integral 0 to 1 minus e x plus adding e and subtracting e by x plus e, or you can write directly f dash x by f of x dx. Here f of x is x plus e, rough work here, f of x is equal to x plus e, f dash of x is equals to, okay, not getting, now integral of 0 to 1 minus e x plus e minus e whole divided by x plus e dx, adding and subtracting e to the numerator. Now continuation part, that is equals to Apply upper limit minus lower limit. First, x into log of x plus e 1 minus e to 0 plus, and this part is taken as a and minus b by c, a upon c minus b upon c, that is equals to x plus e by x plus e 1 integral of 0 to 1 minus e 1 dx minus e constant minus e into integral of 0 to 1 minus e 1 by x plus e into dx. Now x into log of x plus e 1 minus e to 0 plus integral 1 dx is x, limits 0 to 1 minus e minus e into integral of 1 by x plus e dx log of x plus e, limits 0 to 1 minus e. Now applying upper limit minus lower limit, 0 into anything 0 minus lower limit 1 minus e into log of 1 minus e plus e plus upper limit 1 minus e minus lower limit 0 minus e into upper limit log of x plus x is 1 minus e plus e minus log of 0 plus e log e, that is equals to log 1 0 0 into anything value 0 minus 0 0 plus 1 minus e. Next minus e into log 1 0 minus log e base e is 1, that is equals to 1 minus e minus of minus plus e into log e base e is 1, that is equal to 1 minus e plus e, that is equals to 1, which is the required solution of the given 1 square units of the given problem. Next problem, area of the region bounded by the curve y is equal to x cube minus 9x and x axis in square units is, first option 81 by 4, second option 81 by 2, third option 81, and fourth option 81 by 3. Solution: find the area of the region bounded by the curve y is equal to x cube minus 9x and x axis. Given y is equal to x cube minus 9x, we have no information about the point of intersection of the given curve where meets the coordinate axis. If y is equals to 0, that implies x cube minus 9x is equals to 0. Now we can take x common here, x square minus 9 is equal to 0, then x is equal to 0, x square minus 9 equal to 0, x is equal to x square equal to 9, x is equal to plus or minus 3. Therefore x square equal to 0, x is equal to minus 3, x is equal to plus 3. So it is a cubic polynomial. How to draw mark the 0 minus 3 here, 0 3. So in this roots, 3 is the greatest integer, so we can make it as a positive sign. Put a positive sign here and move towards left, alternative signs minus positive negative, positive negative, positive negative here. In positive region the curve is upward, and negative from 0 to 3 region negative, so the curve is downward to the, and 0 to minus 3 towards left it is positive, and here minus 3 to left side it is downward, like this. Now the given curve is x axis, y axis and 0. With x axis y is equals to 0, here minus 3, 0, 3. The graph is like this, 0, and here this is the graph of the rough graph, minus 3, 0, 3, 3 is a positive. So minus 3, 0, 3, 3 is the greatest integer, that's why put positive sign plus, and alternative signs, putting alternative signs towards left from this positive sign, positive, negative, positive, negative. So minus 320 required area is equals to integral of minus 320 above x-axis positive, so y dx, next plus integral of 0 to 3 the curve below x-axis, but area never be negative, we can use mod function here, modulus of integral of 0 to 3 y dx, that is equals to integral of minus 320 y is equal to x cube minus 9x, x cube minus 9x into dx plus modulus of integral 0 to 3 x cube minus 9x into dx, that is equals to x power 4 by 4 x cube integration x power 4 by 4 minus 9 into x integration x square by 2 limits minus 320 plus modulus of integral x cube integration x power 4 by 4 minus 9 into x square by 2 0 to 3. Now applying upper limit minus lower limit, upper limit in both the terms 0 minus 0 upper limit minus lower limit x power 4 minus 3 whole power 4 81 power even number, it will become 81 by 4 minus 9 into minus 3 whole square 9 81 by 2 upper limit minus lower limit plus modulus of upper limit 81 by 4 minus 9 into 9 into 9 by 2 upper limit minus lower limit 0 minus 0, that is equals to 81 by 4, you can take 4 LCM, 81 minus 2 times 2 will go in 4 2 times 2 into 81 162 plus 81 by 4, again here LCM 4, 81 minus 1 81 162, that is equal minus of minus 81 by 4 plus modulus of minus 81 by 4 continuation, that is equals to minus of minus plus 81 by 4 modulus of negative value is positive 81 by 4, that is equal to 2 times of 81 by 4, that is equal to 81 by 2, which is square units, which is the solution of the given problem. Second option is the right option. Once again I will explain this graph. Integral minus 3 to given curve is y is equal to x cube minus 9x. Where the curve meets x-axis, put y equal to 0, means because of on x-axis y coordinate is 0, that's why y equal to 0. After if you will take y equal to 0, x cube minus 9x is equal to 0, it is a cubic polynomial equation, and x common here, x into x square minus 9, x is equal to plus or minus 3. So x is equal to 0, x is equal to minus 3 and x is equal to 3. 3 is the largest integer, that's why put positive sign to the right side of 3 and may put signs alternatives, this is positive and negative, positive, negative, alternative signs towards left for the value of 3. It is a positive, the curve is upward on x-axis, and negative from 0 to 3 it is downward to the given x-axis, and from 0 to minus 3 it is upward positive, and minus 3 to 0 it is downward for the x-axis. So based on this graph, minus 3 to 0 it is positive, so minus 3 to 0, and 0 to 3 it is a downward curve, below x-axis it is a negative part, that's why I can take mod function and substitute upper limit after finding integration of the given problem, x power 4 x cube integration x power 4 by 4 minus 9x integration 9x square by 2 minus 3 to 0 and here 0 to 3, same integration x power 4 by 4 minus 9 into x square by 2, 0 to 3, mod function below x axis. Now upper limit minus lower limit, upper limit 0 minus 0 minus lower limit minus 3 whole power 4, power is even number, that's why it is 81 by 4 minus 9 into again 3 minus 3 whole square 9, 9 into 9 81 by 2 plus and remaining here 3 power 4 81 by 4 minus 9 into again 9 into 9 by 2, upper limit minus lower limit is 0 and simplification minus this is 0 minus 81 by 4 minus 81 by 2, take LCM 4 and 4 goes to 4 here one time, 1 into numerator 81 and 2 will go in 4, 2 times 2 into numerator 81 162 by 4 plus and take same LCM here. This is a minus of minus 81, that is plus 81 by 4 and take modulus of minus 81 by 4 is plus 81 by 4. Here numerator LCM is 4, numerator is 2 times of 81 and 2 will go in 4 and 2 times, that is 81 by 2 square units, which is the required solution of the given problem. Next problem, area bounded by the curve xy is equal to a square. The lines x is equal to a, comma x is equal to 4a, a greater than 0 and x axis is first option a square into log 2, second option a square by 2 log 2, third option 2a square log 2 and fourth option 4a square log 2. Given xy is equal to a square, which is in the form of a xy equal to c square, it is a rectangular hyperbola, that implies y is equal to a square by x. Now a rough diagram draw here. Rectangular hyperbola whose asymptotes are the coordinate axis, and given lines are x is equal to a and x is equal to 4a. It is the required shaded region, which is our required area, x is equal to a, x is equal to 4a. Now the limits are required area a is equal to integral of a to 4a y dx, that is equal integral of a to 4a y is equal to a square by x dx. A square is constant, taking outside integral of a to 4a 1 by x dx, that is equal a square into integral 1 by x dx value log x and limits a to 4a, that is equals a square into upper limit minus lower limit log 4a minus lower limit log a, that is equal a square into log a minus log b. You know the formula log a minus log b, log of a by b, 4a by a. Now a will go numerator and denominator, that is equal a square into log 4. Now log 4 can be written as a square into log 2 square. Log x to the power of n, you know the formula log x to the power of n, n into log x. So here 2 into log 2, that is equals 2a square into log 2. 2a square log 2. So which is a log 2 nothing but ln of logarithmic 2, that is the required solution, that is equal to a square into ln 2, which is the solution of required solution of the given problem 2 xy equal to a square. That solution is the third option is the correct option. Next problem, the area under the curve y is equal to sin 2x plus cos 2x between the ordinates x is equal to 0, x is equal to pi by 4 is first option 2, second option 1, third option 1 by 2 and fourth option root 2. Sin 2x plus cos 2x graph. Draw the, so given curve is y is equal to sin 2x plus cos 2x. Between the ordinates are given x is equal to 0, x is equal to pi by 4. Therefore, required area is equals to required area A is equal to integral of limits 0 to pi by 4 lines. X is equal to 0 is one line given, x is equal to pi by 4 y dx. That is equal to integral of 0 to pi by 4 given y is equals to sin 2x plus cos 2x into dx. Now, integral of sin 2x minus cos 2x by 2 plus integral of cos 2x sin 2x by 2. Integral of 0 to pi by 4 sin 2x plus cos 2x is the given curve. Now, integral of sin 2x is minus cos 2x by 2 plus integral of cos 2x is sin 2x by 2, limits 0 to pi by 4. That is equals to, first apply upper limit minus lower limit, minus, before cos has a negative sign, minus cos 2 into x, x value here pi by 4, 2 into pi by 4 by 2 plus sin 2 into pi by 4 by 2 upper limit minus lower limit cos 2 into 0 minus cos 0 by 2 plus sin 2 into lower limit 0 sin 0 by 2, that is equals to 2 times cancelled 4 and here also 2 times minus cos 90 value 0, 0 by anything 0 plus sin 91 1 by 2 plus 1 by 2 minus cos 0 value 1 minus 1 by 2 plus sin 0 0, that is equals to 1 by 2 minus of minus plus 1 by 2, half plus half, that is equals to 1 square units, which is the required solution of the given problem. Second one is the right option for the given problem. Next problem, the area of the region bounded by the curve y is equal to sin x, x-axis and the ordinates x is equal to 0, x is equal to pi by 3 is first option 1 by 3, second option 1 by 2, third option 3 by 2 and fourth option 2 by 3. Solution, y is equal to sin x is given function, area of the region bounded by the curve y equal to sin x. Now draw a figure. X-axis, y-axis, sin range is +1 to -1 and here 45 degrees pi by 4, and next pi by 3 60 degrees pi by 3 and pi by 2 90 degrees. Now sin 0 degrees 0, so sin 0 is 0, and next sin pi by 2 90, sin 90 is 1, and draw the graph. But given ordinates are x is equal to 0 and x is equal to pi by 3, x is equal to 0 means y-axis, x is equal to 0 means y-axis, and x is equal to pi by 3. So which is the required region of the area, required region of the given problem? Now required area A is equals to integral of 0 to pi by 3 y dx, that is equal integral of 0 to pi by 3 y is means given function sin x dx, that is equal sin x integration minus cos x limits 0 to pi by 3. Now applying upper limit minus lower limit, minus cos pi by 3 minus lower limit cos 0, that is equal minus cos pi by 3 cos 60 value 1 by 2 minus cos 0 1 minus 1 by 2 plus 1, that is 1 minus 1 by 2, 1 minus half 1 by 2 square units, 1 by 2 square units, which is the second option is the right option of the given problem. Next problem, the area bounded between the parabola y is equal to 3x minus 2x square and the x-axis in square units first option 9 by 2, second option 9 by 8 and third option 9, fourth option 9 by 4. Solution: given parabola, given y is equal to 3x minus 2x square. Only parabola equation is given. This parabola bounded between the x-axis, bounded between with the x-axis. So first draw a rough figure. X-axis, y-axis. Now where the parabola intersects x-axis and where the parabola intersects y-axis, if the given parabola intersects x-axis y equal to 0, if y is equal to 0, that implies 3x minus 2x square is equal to 0, 2x square minus 3x is equals to 0. Now you can take x common here, x into 2x minus 3 is equals to 0. Now x is equal to 0, 2x minus 3 is equals to 0, x is equal to 3 by 2, x is equal to 0, x is equal to 3 by 2. Now the curve, if x is equal to 0, substitute in the given parabola equation, y is also equal to 0. So 0 comma 0 is the point of intersection, one point, and next, and again the curve meets x-axis at 3 by 2. 3 by 2 means exactly 1.5. See here 1 and 1.5 here, that is 3 by 2. 3 by 2. So limits integral 0 to 3 by 2 here, which is the required region, required area. Now area A is equal to integral of 0 to 3 by 2 y dx, that is equal to integral of 0 to 3 by 2 3x minus 2x square dx, that is equal to 3 constant x integration x square by 2 minus 2 constant x square integration x cube by 3, limits 0 to 3 by 2. Now apply upper limit minus lower limit. 3 into x square 3 by 2 whole square 9 by 4 whole divided by 2 minus 2 into x cube 3 by 2 whole cube 27 by 8 27 by 8 by 3 minus lower limit 0, x plus lo 0 substitute cheste 0 minus again 0. So that is equals 3 into 9 by 4 2s are 8, and this 2 goes to numerator. 3 into 9 by 8 minus 2 into 27 by 8 3s are 24, and 2 cancelled in 24 12 times, and here 3 4s are 12, 3 9s are 27, 3 into 9 27 by 8 minus 9 by 4. Now here LCM is 8, 27 minus 4 2s are 8, 2 into 9 18, that is equals to 18, 27 minus 18 9, 9 by 8 square units, 9 by 8 square units, which is the required solution of the given problem. Next, the area enclosed by the curves y square is equal to x and y is equal to mod x in square units is first option 1 by 2, second option 1 by 3, third option 1 by 6, and fourth option 1 by 12. Given solution, given y square is equal to x, equation number 1, y is equal to mod x, equation number 2. Squaring equation 2, squaring on both sides, y square is equal to x square. See, this is equation number 3. From equation 1 and equation 3, left sides are same, y square function is same. So we are equating to right side. X square is equal to, from 1 and 3, x square equal to x. Now x square minus x is equal to 0. Now we can take x common here, x minus 1 is equal to 0. X is equal to 0 and x is equals to 1. These are the ordinates or the lines. Now a rough diagram. Y square is equal to x, even powers of y which is symmetrical about x axis, even powers of y which is symmetrical about x axis, and y square equal to x, it is a right open parabola. Y square is equal to x, even powers of y symmetrical about x axis, and y square equal to 4a plus 4ax form plus 4ax form. That's why it is a right open parabola. y equal to mod x. Here limits are x is equal to 0. X is equal to 0 means y axis. This is x is equal to 0, one ordinate, and x is equals to 1, which is x is equals to 1, and the given y is equal to mod x. Mod x is, this is y is equal to plus x and y is equal to minus x. Our limits are only 0 to 1, that's why we cannot take this part, only this region 0 to 1, which is the required area of the given problem. We have to find this area. Therefore, required area is equals to integral of 0 to 1 upper curve minus lower curve. Here upper curve is parabola y1 minus y2 into dx, that is equals to integral of 0 to 1. Parabola is y square is equal to x, then y is equal to root x, y is equal to root x, y square is equal to x. See here, rough work, y square is equal to x, then y is equal to actually plus or minus root x, but y square is equal to x, y is equal to plus or minus root x, we cannot take minus root x because of our limits region is 0 to 1 only, that's why you can take plus root x. And next minus y2 is equal to mod x, that is equal to, you can take only plus x. Mod x is equal plus x, x greater than 0. Mod x is equal to plus x, x greater than or equal to 0, and mod x is equal to minus x, x is less than 0. But our limits, our obtained limits are 0 to 1. From 0 to 1, this is a positive region, that's why you can take mod x is equal, y is equal to mod x is equal to plus x into dx. Now integrating x power 1 by 2, root x means x power 1 by 2, its integration, x power n integration, x power n plus 1 by n plus 1 minus x integration x square by 2, limits 0 to 1, x root x means x power 1 by 2. So in place of n here 1 by 2, applying x power n integration, x power n plus 1 by n plus 1, now that is equal to 1 by 2 plus 1, 3 by 2, it will become 2 by 3, x power 3 by 2 minus x square by 2, limits 0 to 1, that is equal to upper limit minus lower limit, upper limit 2 by 3 constant into 1 power 3 by 2, 1 power anything 1 minus 1 square 1 by 2, upper limit minus lower limit 0 into anything 0 minus 0, that is equal to 0. Now its continuation, that is equals 2 by 3 minus 1 by 2, 2 by 3 minus 1 by 2. Now take LCM 3 to 6, 2 3 LCM is 6, 3 2s are 6 and 2 into numerator 4 minus 2 3s are 6, 3 into numerator 1 3, that is equal to 1 by 6 square units, 1 by 6 square units, which is the required area of the given problem. So 1 by 6, third option is the right option. Next problem, area of the portion of the circle x square plus y square is equal to 16, bounded by the lines x is equal to 2 and x is equal to 3. Is 3 root 7 minus 4 root 3 minus 8 pi by 3 plus k square units. Then k is equal to First option 16 into sin inverse 3 by 4. Second option 8 into sin inverse 3 by 4. Third option 4 into sin inverse 3 by 4. Fourth option 2 into sin inverse 3 by 4. Solution. Area of the portion of the circle x square plus y square equal to 16. So given circle is x square plus y square is equal to 16. That implies x square plus y square equal to 4 square, which is in the form of x square plus y square is equal to r square, whose center is the standard equation of the circle, whose center is 0, 0, center is 0, 0, and the radius r is equal to 4 units. And given x is equal to 2 and x is equal to 3 are the lines. First draw the figure. Center 0, the distance from center to the circumference of the circle is radius, whose radius is 4 units. So the point is 4, 0. Next, here 2 is there, and here 3 is there. X is equal to 2 and x is equal to 3. So we have to find this area. This is our required area. So in this, from 2 to 3, above x-axis area is same as the below x-axis area. That's why you can take our limits is 2 times of, this is one part of area above x-axis and below x-axis another part of area. These two are same portion of area. That's why you can take required area is equal to equals to 2 times of integral of 2 to 3. Our limits is given lines x is equal to 2, x is equal to 3. We have to find in between the x is equal to 2 and x is equal to 3. From above x-axis, this is our required area, and below x-axis also same area. That's why 2 times of integral of 2 to 3 y dx. From here x square plus y square equal to 16, y square is equal to first of all 16 minus x square. Then y is equal to plus or minus root over 16 minus x square, but we cannot take a negative value because of 2 to 3. So that's why I can take positive under root 16 minus x square. Again we can write it as 16 4 square minus x square, y value. Substitute here 2 into integral of 2 to 3, y value is under root over 4 square minus x square dx. You know integration formula, integral of root over a square minus x square into dx is equals to 2 into integral of root over a square minus x square, x by 2 into root over as it is function 4 square minus x square, plus here a square has a positive sign. You can write a square, that is 16 a square by 2, x by 2 into root over a square minus x square plus a square by 2 into root over a square sin inverse x by a. Sin inverse x by a here 4. Limits 0 to 2 to 3. Sorry, limits 2 to 3. Not 0. You have to small correction here. Limits 2 to 3. That is equals 2 into, first apply upper limit 3 by 2. 3 by 2 into root over 4 square means 16 minus upper limit 3 square 9, 16 minus 9 under root 16 minus 9 plus 16 by 2, 16 by 2 into sin inverse of 3 by 4, sin inverse of 3 by 4, upper limit completed. minus lower limit minus lower limit 2, 2 by 2 1, 4 square 16 minus 16 minus 4, 2 by 2 is 1, 2 by 2 into root over 4 square 16 minus 2 square 4, upper limit minus lower limit 2 x plus now 2 ni substitute chesthe 2 by 2 into root over 4 square 16 minus 4 plus 16 by 2 into sin inverse of 2 by 4 1 by 2, sin inverse of 1 by 2, that is equals 2 into 3 by 2 into root 17, sorry 16 minus 9 7, 16 minus 9 root 7 plus 2 8s are 16, 8 into sin inverse 3 by 4, sin inverse 3 by 4, and next again multiplying 2 with this second term, 2 will go, 16 minus 4 root 12 minus 2 root 12 minus 2 root 12. Next again multiplying 2 with this term, 2 into 16 by 2, 2 will go, sin inverse of 1 by 2 sin 30 degrees, sin inverse of 1 by 2 is sin 30 1 by 2, so you can write it as sin of pi by 6, sin pi by 6, sin inverse of sin theta, that is pi by 6. That is equal 2 will go, 3 root 7, next here again root 12 can be written as 4 into 3, 4 coming outside the root 2, so minus 4 root 3 minus 4 root 3, next you have to small correction here, 2 into this one plus 2 into 8, 2 into 8 here 16 here, 2 into 8 16 here plus, and also here 16 plus 16 into sin inverse of 3 by 4, and next minus 8 pi by 3, minus 8 pi by 3. See, you can observe here our given problem is whose required area is already gave here, 3 root 7 minus 4 root 3 minus 4 root 3 minus 8 pi by 3 minus 8 pi by 3 plus k. What is k here, which is in the form of, in place of k here 16 sin inverse 3 by 4, in place of k here 16 sin inverse 3 pi by 4, therefore k is equal to 16 sin inverse of 3 by 4, which is the k value of the given problem.